Hi, this is ENT 201, Quantify the Business Value of AWS. My name is Michael Chu, and I've worked for over 15 years helping clients quantify the business case for technology investments. I work for AWS in cloud economics. Cloud economics helps organizations build business cases to justify the migration to the cloud. And this is what we'll be talking about today. At a high level, there are two primary methods which can be used to build a business case: top-down and bottom-up. The bottom-up business case requires significant time investment, a substantial data gathering exercise, and generally speaking, is perceived to be more accurate. It's the method that most IT organizations that I work with have utilized and seem to prefer. This method can be detailed and time-intensive, but generally leads to a fairly accurate potential business case calculation. Conversely, the top-down approach is based off of benchmarks, utilizes simple calculations, and provides a quick value estimate. It's a method that generally is not used by IT and IT finance orgs when building cloud migration business cases, but it can be just as, if not more accurate than a bottom-up business case. You see this type of analysis done in other arenas as well. For example, analysts will use price to earnings and valuation multiples to determine the value of companies. Real estate appraisers use price per square foot ratios of recent comparable sales to determine the market value of a home. Comp analysis is critical for company valuation because it's based on actual valuations. Similarly, using a benchmark-based top-down approach to build a business case can be more credible than a bottoms-up analysis because it's based on what other customers have actually realized versus a projected estimate based on a model. This quick and simple business case can oftentimes satisfy the management need for a business case. Now, I'm going to first dive into the top-down business case approach and the benchmark data that we can use to help us. To help customers build top-down benchmarking business cases, AWS conducted benchmarking research in 2018 and 2019. We have data from over 1,500 AWS customers about their KPI performance before and after migration to AWS. The study was conducted by a third-party market research firm, utilizes 95% confidence intervals, and is double-blind, meaning the respondent doesn't know that the data is being provided back to AWS, nor does AWS have PII or identifiable information about the respondent. Respondents have to have been on AWS for at least a year so that they can meaningfully provide data. The large sample size is requisite for two reasons. First, statistical significance requires larger sample sets. Second, more data allows us to create highly relevant client-specific slices of data. For example, instead of using the overall average for 1,500 customers, we can get really specific and look at how, for example, financial services companies between 1 and 5 billion in revenue with 5,000 employees performed on the migration metrics. And when benchmarking, the key is that you want to compare to organizations that are most similar to you across the most important dimensions. Now, when we build business cases, the value drivers that we quantify are along the 4 pillars of the cloud value framework that you see on screen: cost savings, staff productivity, operational resilience, and business agility. This business case framework was built based off of hundreds of business case engagements, and it quantifies areas where customers have both realized and quantified value. Right? Customers have told us that these are the 4 areas they realize value. Cost savings is the TCO benefit of migration to the cloud, netting out the migration cost. Staff productivity is the FTE benefit of being able to reduce or eliminate time spent on tasks that are no longer needed with the cloud. Operational resilience is the benefit of improved security and availability. Business agility is the ability to experiment more and respond faster. For customers who are early on in their journey to the cloud, what I see is that typically most end up focusing exclusively on cost savings for their business case. This is fine. You will justify the investment with cost savings or TCO alone. However, the most compelling business benefits come to the right. A recent study done by IDC followed 27 AWS customers, and found that of the total business benefit realized by customers migrating to AWS, 47% of that business value was in the dimension of business agility. 92% of that total business benefit is in the latter three dimensions of area past cost savings. So if there's one takeaway, it's that when you build a business case, make it comprehensive in nature and don't focus it on cost alone. And when we're building a business case, these are the KPIs that are really relevant. And these are the KPIs that we benchmarked. And you can see that they're aligned across the four dimensions of the cloud value framework. And to utilize these KPIs to benchmark, to be able to create a business case, what you want to do is you want to select a peer set of respondents that is closest to you to use as a basis or a peer set for your top-down business case. Benchmarking is the practice of being humble enough to admit that someone else is better at something and being wise enough to learn how and match them and even surpass them. This really is the crux of benchmarking. Base your business case on what other customers who are similar to you have achieved. This makes your business case realistic and credible because the improvement ranges that you set in your business case will be based on actuals of what similar companies have achieved. What I'm going to do now is I'm going to dive into each dimension of the cloud value framework. I'll explain what that area value is, walk through a bottom-up calculation as well as a top-down calculation in the process. I'm going to start with cost savings. Now, when you think about the basic economics of the cloud, let's look at infrastructure costs on the y-axis and time on the x-axis. Typically, predicted demand will go up and to the right. Large, fixed infrastructure spend is added at a step function basis, meaning capacity is added in a step function basis. So that's your dark blue, that's your light blue line on screen. Your actual demand will be wavy and go up and to the right. That's the line that you see below. Everything above actual demand and below capacity, that's your opportunity cost. Customers typically in an on-premises environments will provision 20 to 50% over peak predicted demand for the period. And this is for a variety of reasons. But that's where cost savings comes into play. Customers are over-provisioned and underutilized. A National Resources Defense Council found that the average server utilization ranged between 12 and 18%. A 451 research study found that the average server utilization in on-premises environments was 18%. And McKinsey showed that over 30% of servers were utilized less than 10% of the time. That's the crux of where cost savings comes into play. And why do customers provision over peak? Well, it's because of the lost opportunity you see here shaded in white. This is what happens when your actual demand exceeds capacity. This leads to slow performance, possibly downtime, dissatisfied customers, and potentially lost revenue. And AWS allows you to better match supply and demand. Now, when we think about building out TCO or cost savings, there typically are three dimensions that we look at: server, storage, and network. Now let's take the first row, server. To look at the TCO of servers, you have to look at the raw procurement cost of the servers. But in addition, you need to look at the rack. You need to look at the chassis, the PDU, the top-of-rack switches, and the maintenance on that hardware. Then you have to consider operating system and virtualization licenses on top of that server. And finally, you have facilities costs, which are power, space, and cooling. And you would do a similar exercise for servers, for storage, and for network costs. In my experience, the most challenging areas to quantify and allocate are the right column and the bottom row, facilities and network costs. This is because those costs generally tend to be shared across business units, lines of business, and workloads. I've worked with many customers who have told me, I don't want to put in facilities costs into my on-premises TCO because I don't pay for it. It's free. That may be the case because the company is not billing it back to your cost center, but I guarantee you someone in the organization is paying for those costs. And in order to build an accurate apples to apples TCO comparison, you have to include that in your TCO calculation. Now, when we look at an individual server, on average, the 5-year TCO of that server is 3.5 times the initial cost of the hardware being purchased. And you can see the different categories that the additional costs fall under. Now, what I'm going to do is walk through an example of how to think about building out a business case or TCO analysis for one particular server. Okay, in this example, we're going to go through one non-virtualized physical server that has 16 cores and 64 gigabytes of RAM at approximately 50% utilization. Now, in AWS, this would translate into a C5 4XL. And we're going to do this particular example and this analysis over a 3-year period. So, in the on-premises environment, let's look at the different cost components. So first, you have server hardware. List price from Gartner data shows that this particular server would be approximately $13,000. We'll apply a 40% discount, putting the box at $8,000. On top of that, you have maintenance at 15% per year. On top of that, you have your rack infrastructure costs, including the switches and maintenance on those racks. And we're going to assume that this equates to about $2,000 over the 3-year period for this particular box, which would occupy 2 U's in a rack. And for our analysis, we're going to assume that on average, 28 out of the 42 U's in a rack are occupied. You also have facilities costs, which equate to $10.8K over the 3-year period. This is about $300 per month, $200 in power and cooling, assuming a 750 watt server at a cost of 18 cents per kilowatt hour and $100 for space. Labor, we're assuming that one administrator can manage 100 physical servers at $135,000 comes to about $1,350 per year, or about $4,000 over the 3-year period. And lastly, software. In this example, we're going to keep it simple and assume that this is a non-virtualized server running Linux. If you were to put Windows or VMware, for example, on this particular physical server, you would have to add $3,000 list per Windows license and $3,500 lists per processor for VMware. This leads to a 3-year TCO of about $28,400. Now, in the AWS side, what does this equate to? The cost categories we have to consider are the costs of EC2 over a 3-year period, labor, and support costs. The 3-year RI for this particular instance is 6.5K. We're assuming higher efficiency for labor who's managing EC2 instances versus a physical box of 4X. So the cost here for labor is $1,000 over the 3-year period, and support costs are $10% per year of the EC2 costs, or about $650. This comes to a total 3-year price of 8.5K over the period. And that's it. Now, if we're going to build this top down with benchmarks, what do we do? So let's look back at benchmarking data. As a refresher, this comes from 1,500 AWS customers, and we looked at their metrics before versus after migration to AWS. Overall, for the 1,500 data set, there was a 19% reduction in IT infrastructure spend as a percent of IT spend. When we normalize per user, the IT infrastructure cost per user dropped more than 27.4% after migration. And these cost reductions grow as your applications get larger and more complex. The other additional finding we found was that customers who use AWS exclusively saw on average 12.3% lower infrastructure costs compared to their multi-cloud counterparts. Now, how do we use benchmarking to calculate a top-down estimate of the potential cost savings? Well, let's take the first KPI as an example, IT infrastructure spend. Now, 19% is the reduction seen overall by all 1,500 respondents, but what we want to do ultimately is to make this client-specific and narrow this down for a peer set that's most similar. So going back to our example, what we would do is we would look at financial services companies between 1 and 5 billion in revenue with 5,000 employees and look at what their percent reduction was. We would take that percentage to calculate the potential cost savings for the particular client that we're working with. And it would be based on a similar peer set to the client, which is fantastic. Okay, the next dimension of value we're going to look at is staff productivity. As a reminder, staff productivity is the FTE benefit of reducing or eliminating time spent on tasks that are no longer needed with the cloud. Now, what happens is that as you move to the cloud, you're able to reduce your time spent on undifferentiated, heavy lifting type tasks and increase the percent of time you're able to spend on strategic, differentiated work. The global CIO of GE said something at reInvent a few years ago that really summarizes what we mean. And I'm going to read that. He said, quote, "The things we are going to choose to buy are the things that don't differentiate us. And for us, that's where AWS comes into play. AWS is our trusted partner. I'm not going to sell another aircraft engine because I run a global compute factory well. I'm not going to sell another locomotive because I figured out how to engineer a great user experience for my developers. I'm not going to sell another oil and gas pump or pig because I figured out how to do self-service and build IT infrastructure features." And that is exactly what we mean by staff productivity. So in our modeling, there are 6 roles that we would typically consider in relation to staff productivity: server, storage, network, facilities, application, and security. Each role type would have 15 to 30 different individual tasks that we would look at. In this particular example, we're going to look at a subset of tasks that a server administrator would typically perform. We also show our benchmarks for the typical reduction on each of these tasks. Tasks like installing, upgrading would be greatly reduced, and the cost to arrange for repair of hardware would essentially go away with AWS. So to quantify, let's look at this same set of server administrator tasks, and we're going to assume that this subset consumes 25% of the server administrator's time today. Assuming an average reduction of 75% on these tasks, that is a total efficiency gain of 18.8%. To quantify the full staff productivity benefit, you would look across all 6 role types, across all 15 to 30 tasks per role. To quantify the staff productivity benefit from a top-down perspective, let's look at the benchmarking results for staff productivity. Virtual machines managed per administrator and terabytes managed per administrator dropped by 57.9% and 67.7% respectively. And you can see how re-architecting the applications, looking at just a subset of applications that were re-architected, how that improved gains to staff productivity. And so to do this top-down business case with staff productivity KPIs, we would simply, for example, look at the total number of scoped VMs, the total server administrators managing those VMs, and reduce that ratio by the percent reduction for the relevant peer set. That can then be translated to a dollar amount. It could be translated into number of hours saved, percent efficiency gain, or future hires avoided. This all depends on your organizational context and how you guys want to frame this dimension of value. All right, let's move on to the third dimension of value, operational resilience. As a reminder, this is the benefit of improved security and availability. On screen, you see recent research from the Bottomup Institute that quantified the cost per hour of downtime. Numbers range from $56,000 per hour to over $1 million per hour. I think we can all agree that if we're able to improve the availability of a workload from 99%, for example, to 99.999%, there is a financial benefit to your company. Downtime events may be rare, but when they do happen, there's a significant business impact. And so as a result, it's important to build this particular dimension of value into your business case. How do we go about doing that? Well, recent research, again from the Bottomup Institute, breaks out the cost of downtime into these 9 different cost categories. And not only that, they assign percentages to each of these dimensions. I'm going to walk you through an example where we can use this as a guidepost for us to be able to quantify the cost per hour of downtime. Now, when we're building out the benefit of operational resilience into a business case, there are essentially two key components. The first is the cost of downtime, and the second is the improved availability. Recently, I worked with a media company looking to improve the SLAs of their advertising workload. From the 9 categories of costs in the Bottomup Institute study, they really understood the business user productivity impact when this particular workload went down. They knew that it impacted 1,500 workers, each fully burned at $125,000 per year. And this obviously translates to a cost per minute of $1,500 when this particular workload went down as an impact to business user productivity. Now, they knew that there were cost impacts to the other cost components from that prior study, right? Things like after the fact disruption, detection costs, equipment costs. They weren't sure exactly how to quantify those, but based on the prior study's percent allocations, they assigned 50% of the business user productivity cost to the remaining 8 categories. So they added an additional $750 per minute that the workload was out. And so this is a total downtime of $22.50 per minute. The other thing they had to do was they had to look at the percent improvement in availability. They were looking to go from 99.4 to 99.5, which roughly translates to about 526 additional minutes of availability for the year. Now you multiply those minutes by the $22.50 per minute, and that essentially leads to a $1.2 million annual benefit by improving the availability of this particular workload. Now, top down, how do we go about utilizing benchmarks? The benchmarking data shows that on average, companies reduced their downtime by 56.7%. They were able to reduce the number of incidents by 24.1%. They were able to decrease the critical P1, P0 incidents by 31.8%. And compounding the fact that there were fewer incidents, companies were able to improve MTTR by 39.3%. So when incidents did happen, they were able to resolve them even quicker than before. And again, similar to cost savings and staff productivity, we can use the percent reduction in downtime for your specific peer set to inform our business case. And the last dimension of value is business agility. And again, this is the ability to experiment more and respond faster. Now, the traditional IT model places constraints on innovation, requiring lengthy provisioning processes, slower time to market, cutting into innovation budgets. The cost of failure is also higher, as infrastructure for failed projects must be redeployed. With the cloud, developers can instantly provision and begin writing code. Employees are empowered. The cloud supports a rapid, agile approach to IT that drives competitive advantage. And if a project fails, they can immediately shut down those instances and stop incurring costs. And on top of all this, customers can choose solutions from the AWS marketplace to quickly acquire capabilities to deploy. Traditionally, the software delivery lifecycle goes through 6 major stages. On the chart, we've also labeled the typical percent of time at each step. AWS's built-in security and scalability, third-party services, as well as the ability to deliver cloud-native products greatly simplifies requirements design and reduces the resources required in the first 2 steps. CI/CD pipelines on AWS helps you automate software delivery process, such as initiating automatic builds and deployments. Wait times can be reduced or eliminated through automated application development and smaller deployment batches. And with AWS and many other third-party managed service options, you can also reduce maintenance costs and greatly simplify operations. Now, on screen are the KPIs that our customers have told us that they've realized and quantified value in with respect to business agility. And my recommendation isn't to build all of these KPIs into your business case. It's to pick a handful that really resonate and align with the corporate initiatives that you guys are striving towards. And in the next example, I'm actually going to walk through an example of how to quantify the benefit of improved time to market. So I recently worked with a media subscriber-based company that was struggling with long wait times for users interested in upgrading their service. Now, customers had to wait several minutes, up to 5 minutes, to receive consent forms when they express interest in upgrading their services. And as you can imagine, customers who have chosen to upgrade, who have to wait for 5 minutes, there's a significant drop-off in conversion rates. Now, they looked at upgrading this particular functionality in their on-premises environments and estimated it would have taken them 6 months. They actually were able to deploy this in AWS with a hybrid model in 1 month. And so what that gave them was an additional 5 months of this particular functionality being there, which helped them reduce the time spent waiting, reduce the wait time of their customers from 5 minutes down to seconds to get back the consent messaging forms. And as a result, conversion rates increased dramatically. Now, in this particular example, they knew that there were about 10,000 clicks per month. We multiply that by 5 months. The conversion uplift was 10% for those that expressed interest. And the LTV, or lifetime value, of each upgrade was $1,000. We do the multiplication, and that leads to a $5 million time to market benefit for being able to get this functionality to market 5 months faster. It's important to note that this is a one-time benefit in the business case, as opposed to a recurring annual benefit as the prior areas were. Now, how do we use benchmarking? Again, we see that the time to market decrease from our data set was 37.7%. Customers also saw a 39.3% reduction in the time to deploy code. And lastly, we saw that the code deployment frequencies increased dramatically by over 340%. And similar to the other dimensions of value, we can use these percentages, for example, the 37.7% reduction in time to market, again, looking at the peer set that's relevant for you, to inform our top-down business case. Now that you understand the key components in building a business case and their benefits, let's wrap it up with some best practices. First, it's critical to start building your business case early. Second, involve stakeholders from across the business and get their buy-in and ownership on the business case. And lastly, don't focus just on TCO. Focus on the comprehensive business value that the cloud can bring. And lastly, when building out the business case and quantifying the value, remember there are two approaches, bottom up and top down, and both can be used together or separately. We've gone through examples of how to do both. Most people do bottom up, but don't forget the importance of utilizing benchmarking data to have your business case informed by the value other similar customers to you that have realized. For more information, visit aws.amazon.com/economics. That's our external facing asset page. Additionally, if you would like to engage someone from the cloud economics team to support you on your business case, simply contact your account representative and they'll get you connected with someone from our team. Your team can get started learning with our free digital training courses. We offer over 550 courses, including the 6-hour AWS Cloud Practitioner Essentials course. We also offer a variety of learning paths by solution and by role to help advance skills or prepare your teams for AWS certification. Plus, we also offer enterprise-specific resources such as case studies, ebook, and white papers to help you accelerate and scale your modernization. Again, thank you for your time. We look forward to working with you.